Hi, in this video, I'm going to introduce the law of reflection and plane mirrors. So what's a plane mirror? Notice that the spelling is plane as in like a flat plane, okay, like this piece of paper, and not plane as in, oh, you're boring kind of plane, all right? So this is a flat plane mirror. And basically, what is a mirror? Well, when you get your regular mirror at home, essentially what it is you have a backing. Typically, it is a metal shiny surface. All right, so this would be a metal or a shiny flat surface. And then, of course, you have the backing, which is typically white or like the mirror holder itself. And then the other part is the glass. All right, so there's actually glass and it's supposed to be nice and straight, not my wiggly drawing here, with the same thickness across. Okay, so this is a nice glass surface. So this would here be a glass flat surface. If it wasn't flat, then it'll be warped, okay? The glass typically obviously has no bubbles, okay, no bubbles, and same thickness, thickness throughout. All right, so same thickness throughout. Perfect. So that is your typical mirror. Now, in science class, we're going to be drawing diagrams, and you have to know the symbol for a mirror. So the symbol for a mirror looks like this. You have a line, and this represents the shiny glass. All right, so this here is the surface of the glass. So this here is the symbol for mirrors right here. So this here is the surface of the glass, and then this part here is the backing. Okay, and that is the backing of the mirror. And so you would stand here and you would see your reflection in the mirror. Okay, so how do mirrors work? Well, basically, there's something called the law of reflection. Law of reflection. This law of reflection, all light always obeys. So essentially, what it is the angle of incidence equals the angle of reflection. And some of you are going, okay, that's a very strange law. What does that mean? Well, let me draw a diagram for you. Okay, so I got my ruler here. Okay, and I'm going to draw a mirror. I'm going to draw a mirror, the symbol for the mirror, the scientific symbol. So there's my shiny surface, and this here is the backing. Okay, so this here would be my mirror as I labeled it. Perfect. And I'm going to have a light bulb or the sun shine down, and the light's gonna bounce off the mirror. So I'm gonna take one of those rays, and remember, light travels in straight lines, and in this case, the light is going this way. Okay, so remember, all light rays need to have a straight line with an arrow, so you know which way it's going. And this here is your incident ray. Okay, so remember in the last activity I told you we're going to draw the normal. So that's the next step that we need to do. So let's draw the normal. So another way of doing or drawing the normal is taking your protractor like so, and I'm going to have the intersection right here. Okay, that's between the blue and the red line, and you're going to center it up on your protractor like this. Perfect. Okay, and I'm going to denote that this here is 90 degrees. So I've drawn the 90 degree. Okay. So in this case, it looks like I've drawn the incident ray at 50. Oh, I shouldn't use the, I should not definitely use the protractor readings because that's wrong. I have to count, remember, from the normal. So this is 90, my normal. I have 10, 20, 30, and it looks like 35. So 10, 20, 35 degrees. So this is 35 degrees. Okay, let's draw it in the normal. All right, so we'll draw it in the normal. I had my dot, and I can also use a ruler. That works as well. Okay, there's my dot. All right, so this here is my normal. Normal, perfect. And we did measure it to be 35 degrees with the protractor. Now this here is called the angle of incidence. So theta I is the angle of incidence. So I'll just write here, this is the symbol for the angle of incidence. Now it equals the angle of reflection. So you've already been doing this law in that last exercise, so that's good. Let's measure this out. Perfect. Okay, oh yeah, it's definitely 35. Okay, and so let's actually measure out 35 degrees to draw our angle of reflection. So 35 degrees. 1, 2, 3, and then 5. So right there, that looks like 35. Let's double check. 10, 20, 35. Okay, so that's 35 degrees. I drew my dot, and then I'll draw my angle out this way. And you can actually tell by looking, that looking by eye, yeah, this angle is actually going to equal 35 degrees. And this here is my angle of reflection. So theta R. Don't forget the arrow to indicate this here is the reflected ray. Okay, so you've done that already in the previous exercise. This here is now scientifically the explanation of what you were doing. Okay, now how does this work with mirrors, and why do we see what we see in a mirror? Well, let me show you in a ray diagram. All right, so we're going to draw a nice ray diagram for you. And this is called, or going to be called, a ray diagram for plane mirrors. Perfect. I'm going to draw the ray diagram for plane mirrors, and let's first start off with the mirror itself. So I'm going to draw the mirror, scientific symbol for a mirror. So there's my line, and let's have the backing on this side so that we have you are going to stare into the mirror. So let's actually draw a letter. We'll draw the letter F. That's pretty easy, I think. All right, so what we're going to do is I'm going to take my ruler here. Perfect. And I'm going to draw the letter F 5 centimeters away from the mirror. So notice there is 5 centimeters. Okay, so I got it at 5 there. You can't really see it because there's a 5, right? So 5 centimeters away from the line, and so I put my dot there to indicate that. Okay, and let's make that letter F 2 centimeters tall. So 2 centimeters tall, like so. And we'll do, let's say, 1 centimeter for the top F or top line, and then Well, since we made it 2 centimeters tall, let's do by 1 centimeter, we will do a ½ centimeter. That sounds like a good idea. Perfect. Okay, there's my letter F, accurately drawn, and hopefully you'll be able to draw that as well. So this here is 2 centimeters, that's 1 centimeter. We're going to call this your object, because when you see something in the mirror, you have the real object and then you have the image. So this here is the real deal, okay? Now, in the mirror, when you see something, it's typically the same size, right? So now this is not those enlarging mirrors or those funhouse mirrors or things that make smaller. Just a plain straight mirror. The image is always going to be the same size. And you'll also notice the image is always flipped, like it's backwards, all right? So we're going to draw the image right now. So remember, here's my dot that we started. We measured out 5 centimeters. Well, let's draw 5 centimeters on this side. Okay, if you do that, that means I've lined it up at 5 centimeters. So that means the dot here is going to be 10. Okay, which means 5 centimeters from the line or the mirror, also 5 centimeters that way. So there's 10. And let's also draw it 2 centimeters down, like so. And you'll notice the letter F is going to be backwards. Okay, and I'll explain how that works in a moment. Let's do 1 centimeter like so, and a ½ centimeter for the actual F part. Okay. Okay, so hopefully this is what you have. You have an object, and this is what you see in the mirror. So this is called the image in the mirror. Okay, so in reality, where are you? Well, you could be here, you could be anywhere looking at this image in the mirror. So let's pretend that you're here. Now, in science, we don't draw a person. We actually draw the eyeball, okay? So this is how you draw an eyeball. It's a less than sign. Okay, so that looks like a less than sign, like so. And then I draw a curve to connect the less than sign arms. Draw my little dot and decorate it with lovely eyelashes. And oh my goodness, there is a nice eyeball. All right, so this is your eye. Okay, you have your object and the image. So let's see if this obeys the law of reflection, or basically we're going to draw the ray diagram so you can see it actually does obey the law of reflection. Okay, so essentially this is how it works. Let's draw the incoming ray, all right, or the incident ray. Now keep in mind when you do that, it's going from here to here, but this is kind of tough because you don't know where it bounces off the mirror. So let's actually work backwards. I'm going to take the eye and I'm going to look at the image in the mirror. So here's the eye. Notice I drew the eyeball. We'll do it from the eyeball, okay? And I'm going to point to this dot that we drew. Okay, so I'm going to point to the dot that we drew. So I'm lining up the dots. So here's a dot here, there's a dot there. I'm going to line them up. And you'll notice when I draw the line, it hits the mirror at that point. Okay, and I'll draw dotted lines over here. And I'll explain that in a moment. So essentially what's going on is you have a line of sight. Remember, light can only travel in air. The light doesn't come from the mirror. So you know the light must have bounced off the mirror from the object. So this is your reflected ray. Reflected ray. And then the object comes from here. Okay, so let's see the object. It's from the same dot. You're lining it up to the intersection there. Perfect. And this is your incident ray. Incident ray. So essentially what's going on is the light is coming from F, bounces off the mirror and into your eye. So your eye strongly believes that the image is over here because remember light travels in straight lines and a human brain believes that so deeply that it looks like the light's coming from over here from the mirror. Okay? Now, how do I know that this law of reflection works? We'll take a look at this. Does it look like the angle of incidence equals to the angle of reflection? Well, I think so. It looks pretty equal, doesn't it? But let's double check. I'm going to rotate my diagram this way. I'm going to draw my normal. So remember, I'm going to have here is the intersection. So I'm going to line that up. Okay, so I've lined that up perfectly like so, and here is my normal. Okay, so there is my normal. Right there. Okay, and you can see this here is theta I, the angle of incidence, and here's theta R, which is the angle of reflection. They look pretty equal, don't they? And if you want to double check, let's double check by measuring it. And hey, look at that. We can even count out the angle. So here you go. You have, let's measure the angle of incidence. This would be 10, 20, 30, 40. So 40 and a little bit. And same on this side, 10, 20, 30, 40 and a little bit. Okay, so that's pretty cool. So yes, in fact, plane mirrors are based on the angle of reflection, and that's why they have the same size. All right, and it looks like it appears like it's also from the same distance. Remember at the beginning, I said make sure you do 5 centimeters this way and 5 centimeters that way. Well, essentially what's happening is they're also the same length away from the mirror. So I'll draw that in a different color. All right, and I'll just sort of superimpose that up here a bit from here to here. So in this case, this here is the same length or distance from the mirror. All right, so same distance from the mirror, and that's in the green. All right, you guys need more practice. This here are plane mirror diagrams, so try it out. Oh, look, we just did a letter F, so you could try that. You could try the letter G and try the last here, letter J. Have fun with that, and we'll go to the next topic after this, which is curved mirrors. What happens when there's a little curve in your mirror? Okay, we'll see you then. Bye.